back at IPC Apex 2025 with the Decode podcast, and we have my buddy over here, Jay Patel. I've known him for 20 years, maybe?
Yeah.
A long time.
Sorry, Jay.
And our
Condolences.
dads have known each other for even longer, right?
Yeah, I think
so.
I was going to say we have a special bond.
Yeah.
We're second generation. Well,
Yeah.
taking over from our fathers. You're third generation,
generation,
right? Yeah,
yeah.
second generation for me. So
Is your
we
dad
have-
as crazy as Rick?
I mean, I think everybody's crazy in their own special way. So for me, I think Rick's a gentleman.
Yeah.
But
So Jay owns a circuit board assembly shop out in Troy, Michigan.
Yep.
Right, probably 10 miles from me.
Yeah.
I know. Well, I talk a little bit about Amtech and what they do in this offering wise, but there's like one thing that I really, really want to talk about with you.
Okay.
Vapor phase. He's like the only one around in Southeast Michigan with one that I know of.
Yeah.
And it is so cool, the process of watching it. So I don't know if you want to talk about Amtech for a little bit about, what they offer there, and then we can get into that.
Yeah. So Amtech, we're a typical family owner operated EMS company. My mom and dad started. My mom was a solder tech at Jabil. My dad had PCB fab experience. And I was young and cheap labor, so we decided to start an EMS company. And I think it's been a phenomenal journey for our business. We're a high mix, low volume shop. We like to try to say that we're a quick turn production shop. We don't necessarily want to focus on prototypes, but we want to take projects from conception to production as quickly as possible. And one of the things that we leveraged that we were talking about is vapor phase to get us there.
Yeah, it's just I went to his facility, right, and he's got 2 NEO2s in one line, like super fast, and he's building them up, and then he's like, and then this is my vapor phase, and I look over at it, and he's got like these windows in there, and you can actually see the board come in, and you can actually see the vapor go around it, and you can actually see it working in real time. And what the craziest thing was to him, I was like, well, how do you profile it, right? And then he was like, you don't have to. The board has got thermal profile, right? It's connected to the board.
So, I mean, there is a profile that you need sometimes to preheat it, get the flux activated. But, let's say in 90 to 95% of your cases, it's the heat that's transferring through thermodynamics to the board that actually reflows it. So typically, if we go back, vapor phase was the first reflow methodology, and then IR came, and then convection came, and the reflow, the vapor phase is back, but I don't want to say it's making a comeback, but it's still an option there. And what it basically does is it uses a liquid that boils at a set temperature, which is the physical, or I don't even know. A liquid boils at a set point. So this one is set to boil at 230 degrees C. So when it gets too hot, vapor is produced. Then we introduce the board, which is colder than the vapor, into the entire process. And because of that, the vapor condenses onto the board, similar to a pop can in the summer with humidity, a cold pop can. So then that becomes that becomes a medium of heat transfer to the components. So if you have high mass components, if you have aluminum clad boards, if you have BGAs, the heat goes to where it needs to go to. So the heat would actually go to the ball of the BGA and the land on the board, rather than making that heat sandwich in convection where it goes from top of the BGA component down to the board and bottom up. So you're getting the most robust reflow at the lowest temperature that you can get out there, and
with zero risk of it going over 10, with any components reaching a temp that's not good. It's pretty impressive.
And that's going to result in significant reduction in voiding issues, right? Because you're delivering the appropriate amount of heat.
That's
to
one of
where
its
it needs
biggest
to go.
advantages, right?
Correct. And the nice thing is then we also can get it right the first time. We're not in there doing reflow profiling to make sure that this unique assembly, like we had a customer who had machined an aluminum block and wanted to solder something to an aluminum block. They tried everything, and we brought it in. He said, "Can you try it? Just throw this through the machine." The first time it worked.
Wow.
So it's a phenomenal technology, and especially in a high mix environment, it helps us out because we can focus on production and not process engineering and development.
Yeah. Sure. But there is like one chemical or some type of thing that you have to add to it And
So the chemical, the liquid is called Galden.
Galden.
And I akin it to like liquid Teflon, where it has a fixed boiling point. It doesn't interact with anything. And then so it's able to process it properly.
Is that what creates the vapor? Or
Yeah,
what?
that's what creates the vapor.
All right.
Yeah.
Because it was cool. Is yours batch? I thought it was conveyorized.
Ours is inline.
Okay, yeah.
So basically, it's an inline batch. So you can stage an N number of boards in the staging area. Then that N number of boards goes to the solder area, and then it goes to the cooling area. So it's like it's inline, but it's a staged inline. It's not a continuous conveyor feed.
Because I seen a lot of people online, and they kept talking about doing them in batches with the vapor, and like ridiculous amounts of boards there too.
Yeah.
And I was like, that's not what I seen over at Jay's. You know, you were pumping them through there.
Yeah. So you can get ones that are batch, or you can get ones that are inline.
Yeah. You can get fully automated inline solutions with that. Yeah.
And then little thing too about your company, you introduced some AI part of your company. I don't know if you want to talk about any of that or
for as far as AI goes.
Yeah, like you know how you were integrating the quoting and ordering process. I seen some posts on LinkedIn about it.
Yeah, so basically for quoting, we ended up using a third-party software to help us quote that has ML and all that kind of integrated into that. But we've also been using a lot of AI, and it's something complex right now. Anybody can really use it. I think you're doing a phenomenal job. You're an inspiration in the AI realm.
Right, all of his LinkedIn posts.
No, but we've been able. So now we go. I can't laugh at that because he's semi calling me out too.
No, no, it's literally only him. It's just
so. But we used a lot of GPT internally. Like we had, for example, like we took all of our equipment manuals and taught a GPT on our equipment manuals.
That's awesome.
So now when people need questions, it's available to them. So there's like small things you can do, but as you start doing it, I think we're gonna find more and more ways of using it. It's kind of like when our parents used to use the white pages to find a phone number, and we were like, Dad, we can just Google it on our phone. They're like, what? Like, and like I think we're going through that with this technology right now, except we're our parents.
Yeah, no doubt.
In this analogy.
Too funny. Do you have any questions, Elias?
No, I suppose I have a question about vapor phase. What, if any, drawbacks are there compared to the more widely deployed methods of reflow?
So I think one of the drawbacks is probably throughput. You can get a longer reflow oven to speed and keep up with the takt time of a lower takt time. If you longer takt time, your vapor phase may be able to keep up with it. Another thing is that I think in some applications you have to get a special solder paste that helps. It's called the anti-tombstoning solder paste because of the way that things are done. Sometimes one part of chip components solder before the other one, and then you get
it's a recipe for tombstoning.
However, if you had to pick any type of defect, you probably want to pick tombstone over, unreflowed or partially reflowed BGAs or cold solder joints or anything like that.
You can mitigate some of that tombstoning through effective stencil design.
They're
as well.
easy to see, right?
Yeah, right.
You can see. Yeah, you can see it immediately. And when a BGA is not properly soldered, you can't see it.
Yeah, and you just got the new AOI.
Yeah, so I came to Apex for the first time 3 years ago. I used to think that, why do I go to Apex? If I want to buy something, everybody's going to line up, outside of my door. But I think coming over here, walking the floor, there's a lot of technologies out there that are not mainstream. But if you go talk to people, they'll tell you. And one of those we found was an AI-based tabletop AOI system that takes a picture. You get your gold board right there, and does a comparative analysis using machine learning. And it actually finds the electronic components on there and different things, and it actually can do a quick visual inspection on it. So we've been able to integrate that into our process. So we've kind of codified the expertise of visual inspection by using this AOI system.
Yeah. It's cool to see, cool to watch. If you don't buy from me in Michigan, buy from my buddy Jay. As long
There's
as
enough to go around for all of us.
Listen, if it's on 14 Mile, you can buy from them, right? Yeah. So anywhere else, we'll see what happens. But thank you for being on, man.
No, it was
Good
great.
to see you.
You guys are doing a phenomenal job.
Thank you.
Thank you
Jay.
so much.
Have a good show.